Welcome to Network Freestyle. I'm Daren Fulwell,
And I'm Malcolm Boudin.
and we are the Network Freestylers, back from a bit too long break, I think. But hey, we've been busy, right?
Yeah, that's it. I'd say it's more of a sabbatical than a break.
Sabbatical, yeah, you're probably right there.
Busy guys. The last few months, I think you've had quite a few changes in the family life, and I've just I can't even remember what I've been doing. Probably editing the books and just being a taxi service.
Recuperating from operations and all kinds of things, right?
Well, that's it. The positive on that note is I'm now running. So
this is impressive stuff.
I'm actually kicking a ball with my right foot. So it's happy days. That's all I wanted in life, to be able to kick a ball again. So
you'll be back in the Sunday leagues in no time.
Sunday leagues. January transfer window, and keep telling people. My wife's not very happy about it, but that's a dream. You've got a dream, eh?
Yeah, mate, we've all got a dream. Unfortunately, my dreams are long past fruition on the football front. I'd have gone back a long time.
Yeah.
So we're up to Freestyle 109, right? We're picking up where we left off, and this time we're looking at network migrations. So do you want to fill us in a bit on what we were thinking about there?
Yeah, I think it was just really to switch it up a bit, because I think this is the 9th episode. 109, yeah, 9th episode. So a lot of the early stuff we were obviously finding our way through, and we were obviously conscious around the fact that, you know, some of the videos were potentially quite long-winded, but it was kind of necessary to go into like the low-level detail of each of those technologies. So we then had some of the design principle stuff, which was good, but still hard to get the message across in a shorter space of time. And I think we've still got another couple of those to do. But this was really just an idea to break it up. We've got some ideas about other things, but network migrations happen every day. When I worked in the integrator space, you know, everything was project driven, which resulted in something new being put in and something old being taken out. And whether you just say, oh, I've got a new core switch going in, or I've got a new firewall going in, or I'm migrating data centers, or I'm going to a new WAN provider, every new bit of technology involves a network migration.
Yeah, absolutely.
So I think when we were having a chat about this subject, what we really wanted to do was just to do a high level network migrations episode, and then cover like some of the concepts behind network migration, because, you know, what we talked about and what we talk about a lot is that in network design is that we don't want to reinvent the wheel every time we do something, because sometimes obviously there's no real way around that, and there's things that come from left field once you get into the lower level type stuff. But I certainly, and I know you certainly do the same, is try to template things and have a methodology behind, you know, what we're doing when we have these projects. So I've just evolved the slide. Hopefully you can see it. It's went to the bullet points that we want to talk about. But for example, we'll talk about we're kind of covering the network migration overview at the moment, but I guess the point that we want to get across is templating anything is good to make it repeatable, and that plays well into, you know, the new world that we're going into with programmability, automating repeatable tasks. If you've got standardized designs with fairly standardized migration, not plans, because migration plans are low level, but migration methodologies,
approaches,
concepts, approaches. For example, we've given a few examples here, like WAN migrations. That could, you know, you could open the box on that and go into like 10 different types of WAN migration. But what we want to talk, and migrating a VPN to an MPLS, or an MPLS to an MPLS, or L2 VPN to an L3 VPN, they've all got their own little intricacies on how they're differentiated from each other, and the types of migrations and the types of problems.
Yeah.
However, the high level methodology is the same between. Yeah. And that's really the message that we want to put across, and then give some examples on that for WAN migrations, LAN migrations, and security migrations is kind of like opening Pandora's box. But,
yes, but again, that we wanted to sort of make that point, I suppose, isn't it? And the way I always think about it is that you can implement a network, right, to a CVD or whatever, particularly if you're doing like a parallel build type scenario. But it's how you integrate that and then carry out that migration, and the kind of the approach that you take to do that differentiate you as an individual and your team or whoever it is who's executing on that. It's the approach to doing that, to minimize outage, to maximize availability, that really makes the difference to this. And I think that was kind of the point we wanted to get through here, wasn't it? That the approach you take is really important from a migration perspective for the success of the project. So I think it was.
Yeah, no, I mean that's fair, and I think that I think, without sounding patronising or condescending, the main thing that's going to that people will identify with this is they'll have some level of experience in doing these migrations. So it could be one, or it could be tens, or it could be hundreds of migrations. But if you've done it before, there will be things that ring true to, oh, I've done that before. So so we'll start off with.
Go on, mate.
On you go, mate. No, hang on.
No, what I was going to say was, part of the point of what we're doing here is trying to share our experiences with people who haven't necessarily had the first-hand experience, but can learn from other people's experiences. And I guess that's kind of the whole point of what we're trying to do here, isn't it? So. Yeah.
Absolutely. I keep getting a message saying that there's echo on the line, so hopefully that doesn't affect the playback, but we'll go for it anyway. So what we're going to do first is we're going to cover like WAN migrations. Hopefully you can see this being. I'm not as artistic as Daren, so you need to bear with me. So let's say, right, and the other thing is we're going to really just concentrate on enterprise, rather than service provider scenarios, because again, you add service provider technologies into the mix, and I know there's no service provider, strictly speaking, there's no service provider and enterprise technologies, and that's what we keep telling everyone, and everyone keeps telling us, but the reality of it, there is. So you're never going to use MPLS TE or MPLS in general on a normal LAN. So we don't really want to get into overcomplicate it, certainly for this episode.
That's one for another day when you're doing some of your study stuff, right?
Yeah, exactly. So let's keep a high level, right? And let's say that basically we have two networks. We have one network, red, which is a WAN, and we have another network, which is let's see, blue, WAN 2 and WAN 1. Now, the what we typically have is up here is, I'm going to call it a data center, but it could just be a core site.
Yeah.
And what that core site will have is it will have a number of routers, or it could be multiple data centers. But for the purposes of migration, we're only going to zoom in on to one. So let's say we have the green site, the green links are multiple routers, and that's site 1, site 2, and site 3. And these services then have local area networks with users, etc., located on them. The traffic flow for these to communicate with each other go like this or like this up to the data center, and that's prior to the WAN migration. Now, if I just take that back and we say, forget the data center for a moment, but let's say site number 4, which was previously on WAN 1, is now on WAN 2. And what will I do for data center routers? I'll just make them black routers. So, well, actually, no, I'll make them the color of here. So that's the data center router 1 and router 2. And then we have the similar thing on the new service, data center router 1 and router 2. And then in the middle here, we have a load of, well, let's say at the back end, we call that data center services. Oops, SVCS, data center services. So this is where they call your servers and all that are kept. So at this stage, what we have is the capability to come from here to here, or here to here and here.
Yeah.
We have the capability to go from here to here, and then as more sites are added on to this site, site 5, site 6. These are separate sites. So in this picture, number 1, 2, and 3 are still on WAN 1, and 4, 5, 6 are on WAN number 2. They can communicate to the data center, but at this stage they cannot communicate between each other. So typically what happens, if I come back here and I rub this traffic flow out, and rub some of the diagram out. Sorry, you can tell I'm rusty at the old Freestyle.
All good.
Or you've got a multicoloured WAN 2 now as well. Remove this. Just draw that back in quickly. So now what we have is we know that we can get connectivity at the server, so we're testing the WAN 2 service. We already know the WAN 1 service works. What we need to do is provide some sort of interconnectivity between the two.
Yeah.
So I'm going to cover this quite quickly, but hopefully it will be clear. What do we need to do in order to do that? So let's say, for example, this was like, it's typically what you would have, say these were MPLS networks, for example. Let's say this is AS 1, 2, 3, and this is AS 4, 5, 6, and I'm talking about BGP AS.
Yeah.
So then what we typically have is in here, this might be AS 65001, and this side might be AS 65000, for example. So from a BGP perspective, 65,000 peers to AS123, and 65,001 peers to, sorry, I've actually made a mistake there. So this is probably going to be 65,000 as well.
Yep.
It might be 65,000,
okay.
it could be 65,001. So this is the data center autonomous system. In fact, to make it interesting, let's just keep it as 65,001 because it means that we can illustrate the peering aspect a bit better. So what we then have is some kind of core switch, typically in the middle, which then off the back end of that will typically have the links to the data center side of things. And what we really need to do then is connect AS65000 to 65,001 via the core switch. There's a couple of ways that we can do that. I'm just going to use black lines to illustrate the connectivity into the data center. So what we could potentially do, and one of the things it depends on is who manages the CPE. So the blue routers and the red routers in the data center are the CPE. If it's two different organizations, they normally want to protect what's being advertised into each other's networks.
Yeah.
So and that could be, I realise some people won't be from Europe here who are listening, but managed CPE is very common here. Whereas in like North America and Canada, it's almost like non-existent. And a lot, especially the large enterprises, manage CEs themselves. But typically what we'll have here is the core switch is probably going to be in 65. If it peers BGP, it's probably going to be like an iBGP peering here that already exists. And then what we would then typically do, I'll illustrate it. That would peer eBGP to the new infrastructure. Now, what basically happens is that let's move to the actual let me think how to describe this. Let's move to the actual migration and what the challenge is here. So let's say this site number 3 is cut off from WAN 1 and moved over to WAN 2. In fact, let me just change that. Let's say we need to get WAN 3 onto WAN 2, okay? And at the moment it exists and it's advertising 10.3.3.0/24.
Okay.
When it comes over to this side, it also needs to advertise 10.3.0.0/24. So what we need to do is take this off the network and effectively remove this off the network before we can actually bring it onto this side of the network, even though it's a new CPE device. And then what happens there is that it's the same LAN which is configured. 10.3.3.0/24 is now available on this side, but it's not available on the other side of the network.
Okay.
So that's propagated into here via BGP, eBGP, and then it's propagated up towards this switch via eBGP. And then via iBGP, it says now if you want to get to, if for example 1 wants to speak to 3, it learns that it's now no longer has the traffic flow like this. It has to go up to the data center and across and down into the new network. So basically, the key point here, that's probably a long-winded way of saying that in order to do a WAN migration, the methodology always includes a requirement to go via not necessarily a data center, but a core site.
But a transit site, yeah.
A transit site, a core site, and that's normally something that has like a decent amount of bandwidth, not only on these new circuits that are highlighted in blue.
Yeah.
But it's, to be honest, because they're probably going to be more than adequate if it's a WAN upgrade or a WAN migration.
You'd hope so, yeah.
It's more these circuits that you're going to be concerned about to make sure that they're capable of supporting traffic coming from another network.
So your site to site, sort of kind of spoke to spoke type traffic. Yeah, that's
because previously, exactly what you say there. So this brown sort of coloured line that goes down to 10.33.0.0/24 from site 1 to site 3, that was normally being kept local. That was normally being kept local over this link. Over this traffic flow within a single MPLS. So it was obviously coming this way to get to the servers, but that's a lot lighter load than traffic potentially depending on the organisation. Yeah.
So I guess the thing to watch for here then is when you're doing that kind of a migration, if you're taking sites from an old WAN infrastructure onto a new, and you're concerned about the level of traffic flow that you're going to end up putting across those DC links temporarily, then think about how you group sites together and migrate them together, I suppose. I mean, if you've got, for example, a lot of video traffic or some important voice traffic that traverses between those spoke sites, I guess you can bundle those together as part of that migration approach, and migrate them at the same time onto the new WAN.
Yeah, and I think one of the other things that one of the other things that is for consideration is how you or if you and how you accept the routes after they've been migrated. So, for example, let's just draw something in here in green, and let's just say you've got that, which is a back-end interconnect that goes between two sites.
Yeah.
I mean, that in theory that should be planned against in the design phase. You should identify sites that have got dependencies on each other, but there may be a reason why. Let's put a scenario together. Let's say site 6 had to move because their lease was expiring.
Yeah.
But where the point-to-point circuit goes, they still need to have whatever traffic flow goes over this point-to-point link.
Sure.
This one here. So there's traffic being sent over that point-to-point link, but it goes from, instead of going from the old location to the old location, that office building might have closed, they've had to move, and when they've moved onto the new WAN, but they still need the functionality of the back-end links, because there might be applications based at that site that are dependent on that link or whatever.
So basically you're putting in temporary links in order to circumvent that problem of bringing the bandwidth, tuning the bandwidth in the DC, and I guess having the additional latency of two sets of WAN links and whatever in order between sites.
And that actually brings another challenge from. I don't want to go too deep, so this will be the last thing that I'll round off on WAN migration. But where I was actually going with that as well. So yes, the bandwidth aspect. It might be like, oh, we're getting this shiny new WAN, we're getting our new links, and they'll say, oh well, let's just put the replication traffic or whatever that traffic is over the new WAN link. But it doesn't quite work like that. because these are normally like fairly low latency back-end links that are put there. Well, they're either put there for one of two reasons normally. It's either cost, because it's in a metro area and it's less expensive, or it's latency. You know, if they need something to be like 10 milliseconds or 20 milliseconds or something like that, it's more predictable over a point-to-point link than it is going to be over a WAN. But one of the other things this also causes, potentially, if that was a routed link, this 10.33 could potentially be advertised in a loop.
Yeah.
So what we really want to do is like tag this in some way with like a BGP community, for example. So when this route is advertised basically up to here, what we want to do is, let's say we tag it with in BGP with 65.0.0.1 colon, I don't know, 2 for WAN 2. And then what you can do is then start enforcing traffic policies, like, so at this demarcation point here, you can, when you accept eBGP routes into 65,000 from 65,001, you can say only accept routes that have a BGP community of 65,001 colon 2. They are then propagated into this network to be reachable over here, you know, on WAN 2.
Yeah.
But it also allows you to then say at this point, it would be there. It would be slightly further up. It would be this point. You could then say, if this is just logic, this isn't actual syntax. But if 65.0.0.1 colon 2, this kind of, then do this. And the do this might be redistribute into OSPF with a tag of 2. And then the OSPF routing would then say, right, block it from being re-advertised back in here and causing a loop.
Yeah. So it's that kind of, it's almost the mutual redistribution problem, isn't it? But the equivalent of just blocking the routing loops by using tags to identify the origination of that route. Yeah. Which is, I mean, good practice anyway, but you know, a really useful tool for when you're doing exactly this. Yeah.
And I think the key, so just to round off on that one, but mutual redistribution, but it's not mutual redistribution as you see in most like diagrams and training videos. So you might see, you know, a mutual redistribution thing that looks like this, where it's like routers like that might be connected. Yeah. I don't know, something like that.
In a square or whatever.
And this is OSPF1, and this is EIGRP. And you know I guess it would be like that. But you get the picture. Like it would, if this is OSPF and this is EIGRP, it's normally, you know, you don't want it to be redistributed into there, redistributed into there, redistributed back, and redistributed back. Yeah. But see, if you look at this WAN migration, which is actually quite straightforward WAN migration, because we've hardly put anything in here. It's only a few sites. Your mutual redistribution is actually separated at separate ends of the infrastructure. So you might have like redistribution, you know, up here at the data center, and then you might have like multiple other data centers, and then you might have redistribution or mutual redistribution going on at a site that has a back end link. It's
an interesting one because the the mutual redistribution problem, as it's always done for certification labs and all the rest of it, is quite a rare occurrence, I would have thought, in real networks. And yet the technique is very similar to the approach that you would take in this scenario, which is much more realistic, right? And so I think it is sometimes that thing of you can learn something theoretically, but it's only when you come to have the experience of going through a migration like this that you actually learn to put it into practice, and in a different scenario than you'd expect.
Yeah, and another kind of gotcha that could happen here, for example, if this back end link was in place for whatever reason, let's say somebody forgot to advertise the default route from AS 65,000 down into this network, or there was some metric configuration that made it depreferenced or something that caused a loop, you would still get like the default route in this way.
Yeah.
So, you could have like asymmetric routing, and then when something disappears upstream here, and you've got no default route coming from this way and no default route coming from this way,
yeah,
you're in a bit of a pickle, and then your internet goes down or whatever. So anyway, we're getting into like low level territory. So.
No, but like you say, it's really a case of when you're going through that process, know your routing, know what you're trying to do, know what you're trying to achieve. I mean, there's, you could we won't go further into it, but if you had a backup in a scenario as well here, where you weren't just moving a single link, but you have backup links as well into another network, and there's another layer of complication. Mm-hmm. The point is that if you understand your routing properly, then it's going to help you out, particularly if you need to worry about those backdoor links, if you like, for the temporary.
And this is where you don't have documentation for your network, or accurate documentation, or tools to be able to understand what the traffic flows and stuff. I know things like that are getting better with SD-WAN, but if you're wanting to move to an SD-WAN and you've not got a clue how this stuff flows, then you have to be on your toes.
Of course, and this is no different, is it? I mean, you're talking about an SD-WAN migration, you're still going to have to go through something very similar to this, because SD-WAN stops somewhere and has to connect to the wider network. So there's always that point where you've got an edge of the SD-WAN and an interaction point and a transit point between the old network and the new and the data center. Mm-hmm. That's still
I think we demonstrated some of that in the SD-WAN generic video, and some of how like the migrations can look, and the I-WAN and the Viptela videos. So if you're interested more in that, I think we covered some of the migrations.
Do hit those videos, because they're I think there's some useful stuff in there.
Yeah, well, I think we illustrated where, for example, in this scenario, it looks like WAN 1 and WAN 2 would be like separate providers. When you're migrating to an SD-WAN scenario, they look like separate providers, but they might not necessarily be. So it could be, an overlay on top of the same underlay that the existing network is on. And and this is what we're talking about, the concept.
Yeah.
You still effectively need to go up via the data center or a transit site for an overlay to talk to the underlay network.
Always. Yeah, and that becomes interesting and complex because of that interaction between overlay and underlay, for sure. But it's like you say, think of it as a separate network. Think of the overlay in an SD-WAN as a separate network, and think of it as a migration process like any other. That's the way forward.
Cool. All right, so hopefully that demonstrated us a fair bit to think about with WAN migrations, and that was quite a straightforward example and a concept. But the key driver there was, if you're going from one WAN to another, you're going to need to transit through something and work out all the routing, backdoor links associated with it, routing protocols, interoperability, etc., etc.